Okay, so ang lesson ngayon ay estimation. Now, estimation, according to this, is an area of inferential statistics concerned with trying to determine the true value of the population parameters. First of all, there are two branches of statistics. The first one is descriptive and the other one is inferential. So, descriptive, ito yung we are trying to describe what is given, kung ano lang yun nandyan. But for inferential, ang ginagawa natin, kumukuha lang tayo ng part, and then yung part na yun yung magre-represent sa population. Sila yung magre-represent para sa buong population, no? Kaya sabi nga dito, with trying to determine the true value of the population parameter, we are not to know what the value of the population parameters, but we are what do you call this, try, yun nga, sabi nga dito, na alamin natin kung ano ba, kung saan siya ba nagre-range. So, estimator, any statistic whose value is used to determine or to estimate rather an unknown parameter. So, estimator, these are mean, standard deviation, and variance. While yung estimate, kung ano man yung value ng estimator, yun yung estimate. For instance, ang mean ng age ay 17.82. Yung mean itself is an estimator, while the value 17.82 is the estimate. Now, point estimate, I already explained this weeks ago. Pinagkaiba niya sa interval estimate, pag point, isa lang. Pero kapag interval estimate, meron tayong range. Okay? We also have this what we call the degree of certainty attached to an interval estimate for the unknown parameter. That is 1 minus alpha. Ang tawag natin dun ay level of confidence. The usual level of confidence is 90%, 95%, and 99%. Or those are the usual level of confidence that we have. So these are masasabi natin na kung gaano ba tayo kakumpiyansa doon sa interval estimate that we have. So, next. Okay, so examples lang ng point estimate, no? Sabi ko nga kanina, for statistic, we have x bar, sample mean, standard deviation, and sample proportion on the right side, while on the left side, population mean, mu, population standard deviation, sigma, and population proportion, we use p. Now, for the first example, we have here the number of incorrect answers on a true or false test. For example, for a sample 15 were recorded as follows. So those are the numbers. Now, find a good point estimate each for the mean, standard deviation, and variance. So all we have to do is to compute for the mean, standard deviation, and variance of these. And for the proportion, sample proportion, in a certain class, 5 out of 45 students are left-handed. So, estimate the proportion of left-handed students. So, yun lang yun, no? 5 over 45. That is the sample proportion. Now, let us have this. Interval estimation of the mean of a single population. So, confidence interval for mu, and we have this condition that the standard deviation is known. So if x bar is the mean, sample mean rather, of a random sample size n from a population with known variance, so take note, the variance is known here, and the level of confidence is given by 1 minus alpha. By the way, alpha is the level of significance. 100% level of confidence interval mu. So, ina-estimate natin yung population parameter mu is given by, makikita nyo, sa gitna, nandun yung population parameter. Okay? Nandito siya. Oops. Wait. And then, napapagitnaan siya ng x bar, tsaka ng x bar din dito. Yan. Kung mapapansin nyo, halos parehas lang itong dalawa. Pero ang pinagkaiba lang nila dito ay plus, dito naman ay minus. Ibig sabihin lang ay para i-estimate yung population parameter o population mean, dun sa sample mean magdadagdag lang tayo na itong value na ito para makuha yung upper bound na tinatawag, yung nandito sa kanan, at magsusubtract lang tayo nito sa sample mean para makuha yung upper bound or lower bound, or given na n is 30. Now, to give you an example, by the way, ito pa lang, ito ay tinatawag na, pati ito, tinatawag silang error. Now, ito pala yun, sabi ko kanina, confidence level 90%, 1.645, 95%, 1.96, 99%, 2.576. So, ayan. Next, a survey of the deliberate time of 100 orders worth 20,000 from Green Cab yielded a mean of 55 minutes with a standard deviation of 12 minutes, assuming that the deliberate time follows a normal distribution. So we are asked to construct 95% confidence interval for the true mean. Now, for the first example, saan yung first example? Yan. So, for the first example, nagdi-discuss ako. Nagre-record ako ng video kasi absent ako ngayon. Ayan. Yun sunod. For the first example, we can say that n is 100, x bar is 55, and s is 12, or the standard deviation is 12. Based on my previous or what is written here, mean is 55, n is 100, and standard deviation is 12. Okay. Now, we can say that the value of z is 1.96 according to the table earlier. So here is the formula. Now, I replace x bar by 55. I replace z by 1.96. I replace 12, or I replace sigma rather by 12, and n by 100. Ganun lang din dito sa kabila. Halos parehas lang sa sila. Ang naiba lang, dito ang subtraction, dito addition. So, if you're going to compute for this, shows that its value is 2.35. So, kung ano yung value dito, malamang yun din yung value dito. So, this is also 2.35. Okay, so 55 plus 2.35, obviously that is 57.35. And 57 or 55 minus 2.35, it will be 52.65. So it goes to show that the true population mean, or the true mean, lies between 52.65 and 57.35, with ang level of confidence natin dito ay with 95% level of confidence. So doon na tayo sa next example. Dito naman ang naiba lang, parehas yung given, pero yung naiba lang yung value ng z. So ang value ng z dito ay, mapapansin natin, 2.576. So ayan yung value ng z. Then ito yung formula. So next slide. So ayan, ang napalitan lang dun kanina, parehas lang halos lahat bukod dito sa value ng z na 2.576. And as you can see, this one, pag nilagay natin sa calculator, ang value ng 3.09, pati ito 3.09. So 55 plus 3.09, 58.09, 51.91 ang resulta if we subtract 3.09 to 55. So meron pa ba? Mamaya na. That's all for now. Mamaya na iba.